How's everybody enjoying their show so far? Good. My first time down here, I remember what heat and humidity was coming from Michigan, so a little bit. All right. Well, welcome to my session. We're going to talk about indoor air quality. A little bit about myself. Like you mentioned, my name is Brynn Cooksey. I kind of got two roles in the business. I am a home performance contractor back in Michigan, and I also own a technical training business. The contracting business is kind of what the presentation is built on. And one of the things I wanted to do when I was in my contracting business, I wanted to get out of the rat race. Do you guys know what I mean by that? Box swapping, rat race to the bottom. All right. When I learned building science and I started thinking about how to test and measure everything I did, IAQ became an instant profit center. So we're going to talk about that, how to manage it. So our objectives, we're going to talk about the IAQ market. When I talk to techs and contractors, is there money in IAQ? You'll be surprised. We're going to talk about different IAQ issues, how to measure the parameters. We're going to talk about strategies and also ventilation. So my call to action for this course is I don't want you to forget the V, ventilation, really important, all right? A couple references that we put this presentation together with the help of Air Advice, Building Performance Institute, and the DOE. All right, now why is this important? Well, if you look at the DOE or EPA, they put out information that we spend about 90% of our lifetime indoors, right? And when they've measured the air quality versus indoors versus outdoors, they find that it's about 2 to 5 times worse indoors than outdoors. So when we look at it from a contracting perspective, IAQ issues often go really misdiagnosed. So from a contractor's perspective, what got my attention years ago to measure IAQ was the ability to benefit from it, all right? Now, when we talk about IAQ, there's several issues. You have moisture and mold, or biological growth. Customers store toxic materials in our house. We got carbon monoxide. There's been a lot of discussion about that in the conference. You got radon, sewer gas, and a host of others. All right, so IAQ issues are common in a lot of the homes we go into. Now, what determines IAQ is not only the substance, but it also has to do with the customer and how they interact with it. On the far left, you see some unstored chemicals, right? Who knew that some of those chemicals off-gas through their bottles? Have you ever heard that? All right, a lot of people store those underneath their cabinets or their laundry room. As an auditor for many years, I've popped many attic hatches to come to my surprise and see an attic full of mold, all right? What about kerosene heaters? You still run into that. You got store fuels inside your garages, unvented attic fans. What about uncovered sump pumps? Do they put water vapor inside the house? Yeah, they sure do. And then in the last picture on the far right, somebody was kind enough to put chemicals near the return air for that furnace, all right? So IAQ is a fairly prevalent problem in a lot of the homes and businesses that we go in. And if you're not measuring IAQ, you're missing the boat, okay? All right, the occupant also contributes to this IAQ issue. Things like excessive pets or that pet dander, they can trigger allergy and asthma issues. What about VOCs? We're gonna talk about that exclusively, including solvents, paints, and other cleaners. Other unhygienic issues, and even our creepy crawlers, like maybe our mice and their activities, they're also allergy triggering and can promote asthma. And then, to make it worse, our industry is making houses tighter and tighter and tighter. And when you have uninformed occupants, you create indoor air quality problems, okay? So customers know the symptoms, but not necessarily the solution. So they're buying the allergy medicines, they're buying the inhalers, but have they treated the indoor air quality problem, or are they solving their symptoms? Okay, pretty important. Consequences of improper indoor air quality includes allergies, headache, fatigue, asthma-like symptoms, and flu-like symptoms, right? It could be something as small as us making an adjustment to our HVAC system. All right, how big of an industry is it? The big box stores report that it is about a $10 billion industry, all right? 10 billion with a B. So consumers are going in and they're purchasing devices to try to solve their problems, but they're not resolving the root issue of the IAQ issue. So when I train techs and contractors, I say, hey, when you see these things like an air purifier, a dehumidifier or a humidifier, that customer is trying to solve a problem, right? They're spending money trying to solve a problem. They're solving the symptom and not addressing the root problem, right? So let's insert the HVAC tech. When I run reports at home, my standard techs, one tech is usually in about 1,000 houses a year, all right? And when you look at it being such a prevalent problem, there's a huge market share of potential revenue that you can gain by measuring IAQ. So the HVAC technician, among all other people, are the front lines for IAQ. Another really interesting point about the HVAC business specifically, every cubic foot of air in that house eventually goes to that air handling system. As a result, HVAC techs are prime candidates to test and measure for IAQ, all right? $10 billion industry, all right? So when you measure IAQ, we're gonna discuss how in a moment, but I want you to think about when I'm measuring IAQ, what am I looking for and how can I use this in our market, all right? Now, IAQ should be done on a consistent basis. Who measures for IAQ currently? All right, who do it on every single service call? All right, you are missing huge opportunities by not testing. I test with our contracting business every single service call we go on, every single house, all right? It is as common as a temperature or pressure or electrical measurement. That's how frequently we test. And when we test, the goal is to determine what type of issue it is and also how bad the issue it is. And like I said, every single service call, we're testing for IAQ. Yes, sir. Very good question. His question, do we disclose that to our clients? Yes, we do. When they call in, our CSR has a script, and I'm gonna get into how we actually do it in the house. So here's my monitor. And on the right side of the screen, these are different parameters that we measure on a fairly consistent basis. Okay, every single call we go into, these are the parameters we test. So our script, if you will, when clients call into our office, we disclose that we're gonna be doing some IAQ testing, and most of the customers are receptive to it. Matter of fact, they are really interested to see the results. When we test, and we'll talk about how we do it in a moment, we come up with these parameters. So my particular device, I plug it in, I let it run for a half hour, and it comes up with a report. And based on that report, I can have a conversation with the customer about what's going on, okay? So initially, we test in, okay? We test in, that's the key principle here. You always wanna test. Once you test, you come up with some type of solution, whether it's gonna be a ventilation strategy, or whether an enhanced filter, MERV 13, MERV 16, some type of solution to eliminate or reduce that IAQ issue that they had. And when we're done, we test out. All right, this is the same exact, this is the actual job we did. And if you look at the differences, that was before, we implemented our solution and we tested out, okay? Every single call. As you see, everything improved, everything is in the right parameter, we got a happy customer, okay? Test in, implement your solution, and test out, all right, IAQ. Now, the types of tests that we do. Our initial test, we do what's called an as-is test. And that's a test, we show up to the customer's house while the technician is plugging in their monitor. It runs for at least 30 minutes. It gives us a snapshot in time, all right? It's not the greatest test because it doesn't run long enough, but it lets us know, should we be diving deeper to look for problems, all right? It may not help you troubleshoot, and we do this as a service, all right? We do it on every single service call. A long-term test, I have left monitors plugged up for months to kind of help a customer troubleshoot an IAQ problem. That provides some type of context as far as time. One situation that comes to mind, I was able to see exactly when a customer was cooking and their exhaust fan wasn't working, all right? Long-term tests can also change the way the information is provided and give you some graphical information. We view this as a product. When somebody calls our office for IAQ, we typically charge for this type of service, all right? So as is testing, snapshot. We're looking at it, all right, 30 minutes or so. Do we have anything glaring that we need to investigate? And long term, all right, a little bit deeper dive. As you see here, I'm able to put more time context. I can ask the customers additional questions. I can actually see exactly what's going on so I can solve their problem, okay? So that's long-term testing. All right, now we're gonna talk about 6 IAQ parameters, what they are, how to measure them, and when we measure them, we're gonna talk about how to resolve it. First one we're gonna talk about is particles. And when we talk about particles, I want you to think about stuff, right? Liquid and solids that are floating around in the air, all right, they're stuff, all right? When we talk about particulate matter, we're talking about that stuff. Now, with particles, the small ones are the most hazardous, and we'll talk about that. In particular, PM 2.5. That gets past our nasal passages and our respiratory defenses, and it gets embedded deep into our lungs, and it can get into our bloodstream. To give you an example of what PM 2.5 is and why it's so concerning, if you look at the screen in the middle, you see you have a human hair. All right, human hair is roughly 50 to 70 microns. Well, if you look at PM 2.5, the physical size comparison is to the right of the human hair, but the actual size comparison, if you look a little bit below that, is really small. That particle can bypass all our natural respiratory defenses and get into our bloodstream. There have been studies where it has been proven that particles in the bloodstream can cause issues such as dementia, right? So particles is one of the first things that we look at to try to stop, right? Now, when we measure particles, we're looking at the type of particle, and we're gonna measure it in a cubic foot. All right, well, like I like to describe to customers, a basketball of air, a cubic foot, a box. And we're gonna measure it by micrograms per meter cubed. And that's gonna give us a concentration, all right? When we look at that concentration, we're gonna compare it to a reference point. So the World Health Organization, they say that 35 micrograms per meter cubed is enough of a particle dose to cause people that are vulnerable, such as elderly and children, to have some type of immune response to particles, okay? With 2.5 being the most concerning, and the EPA has even listed it as one of the top 5 health hazards. Anybody from the US or Canada that was affected by the wildfire maybe a couple years ago? What did they tell you to do? Stay indoors? Pretty much, all right? They were concerned about PM 2.5, okay? All right, what can it do? Once it gets into your bloodstream, you can't really get it out, and it can irritate your eyes, your lungs, and it's caused by chemical reactions, construction activities, emissions from the combustion process. All right, so PM 2.5 is the most concerning. As we interact with our customers, we'll go and we'll do our testing, and if we find PM 2.5 or particles elevated, we'll have a conversation about how to resolve that. Controlling particles, they can come from indoor, outdoor sources. They can come from processes such as cooking. Anybody got a gas range at home? Unvented, does it have an exhaust vent? A lot of the houses we walk into, they don't, or they're not operable. So as a result, when we measure that, especially after dinner, we get a high particle concentration. What about air fresheners? Do the ladies light candles? Yeah, all right. Could cause a VOC. I see your face. Don't agree with what I'm saying, but it's okay, all right? Unvented combustion appliances, cigarette smoke, cleaning products, they all can produce particles, all right? Well, remember, with 2.5 being the most concerning. All right, so the key is to controlling particles, number one, we want to control the source. So when I say control your source, especially ladies with the candles, don't get rid of your wife, get rid of the candle, not the wife, okay? All right. You want to do things like duct cleaning and duct sealing, and maybe enhanced filtration systems, all right? And we're going to talk about ventilation at the end. Don't forget the V. All right, so control the source. That's the number one principle for IAQ. Always want to stop the bad stuff as it's occurring. Contrary to popular belief, there's no product, no solution that you can add that's going to resolve IAQ problems. It just doesn't occur. All right, controlling the source is the first thing. Okay, filtration with particles, I can filter those particles out of the airstream and remove them as they come in. And the reason why, remember, every cubic foot of air eventually goes to that air handling system. So when you want to remove particles and you didn't stop the source, filtration is the way to go. All right, be mindful before adding the filter. They have various pressure drops, and it may be required that you do a duct modification to accommodate that pressure drop. All right, so make sure you size your filters correctly and make sure that that duct system can handle that more restricted filter. My favorite, MERV 13, and if I have enough room for airflow, I'll go MERV 16. Usually when I put that, I see particles plummet, okay? There's a big controversy out. You have two people in the world. You got duct cleaning and non-duct cleaning people. Who are the non-duct cleaning people? All right, don't believe in it, right? Think it's a scam. All right, we've heard conflicting information from the EPA where they don't agree with it. Then we have other organizations that run studies. I've seen and measured improvements after we've duct cleaned, so I'm a duct cleaning guy, okay? What duct cleaning does, basically, this is our duct distribution system. We block off all the intentional openings, our supplies and returns. We put the duct under a negative pressure, and then we use a combination of tools such as air compressors and brushes or augers, and we push the dirt and debris to that high pressure negative vacuum, a HEPA vac, all right? When I talk to customers, it's kind of tough to convince them that that didn't help. So you see the before and after, right? We have launched our air monitoring tool, took a baseline of particles, and then performed duct cleaning. We let the system run for a couple weeks, and we came back to take a post measurement, and we have seen a reduction in particles. So we totally believe in duct cleaning. I didn't have enough time to put it in the slide, but there is a study that just came out where duct cleaning actually reduces fan power, and increases airflow, increases system capacity, and reduces particles. And if you're interested, I'll send it to you, okay? For those non-believers. All right, what about duct sealing? Is that an IAQ issue, or could it contribute? Absolutely, especially ducts located in unconditioned space or in conditioned space on a return side, all right? So duct sealing is super important. Now, before you duct seal, you have to do what? Make sure the duct is what? Size appropriately before you duct seal. If you duct seal and the ducts are not sized appropriately, you're gonna have serviceability issues with that equipment. Here's one of the processes that we do. This is a duct process where we go in and seal ducts using a solution called AeroSeal. AeroSeal is awesome because we can take a liquid rubber, we can turn it into an aerosol, and we can pressurize the duct system, and it goes and seals all the holes, the gaps, cracks in the duct system that were there when a duct was put together. And when we seal the ducts up, we reduce the capability or the chance that on the return side, I can pull in particles that were not healthy for me to breathe. Nice thing about AeroSeal, you can do it without the walls being demoed. You can actually seal the whole entire duct system without actually destroying or having lack of access to your duct system, okay? So that's particles. Next thing we're going to talk about is chemicals, AKA VOCs, all right? Now, when we say chemicals or VOCs, we're talking about volatile organic compounds. Volatile meaning that a solid or a liquid will readily turn into a vapor at low temperature, say room temperature. So they're volatile. They'll turn from a solid liquid to vapor, a vapor to a liquid to a vapor really, really quickly, all right? These vapors or gases, they come from many of the building materials that we have in our house and also the cleaning chemicals that are inside our houses. And when they off-gas, those off-gas vapors can trigger our asthma and allergy symptoms, okay? All right, so I have a brother, older brother, and he historically has had issues with his asthma. And once we tested his house and identified that he had VOCs triggering it, we were able to have him use his inhaler a lot less, okay? So chemicals or VOCs trigger allergy, asthma, and other respiratory illnesses, and they're everywhere. They're everywhere. They can be inside your solvents, your glues, stored fuels, combustion materials, your drapes. Who has bought a nice shirt from a department store, all right? You know how the shirt looks all nice and neat when it's on that department store shelf? Guess what it's laced with? Formaldehyde. Formaldehyde is one of the biggest IAQ issues as far as chemicals go. All right, formaldehyde and benzene are everywhere. All of our cleaning chemicals, if you go home and turn that can over and read the label, guess what it has in it? Formaldehyde, all right? So they're everywhere. What is formaldehyde used for? Anybody ever had stuff like this in biology class? All right? Formaldehyde is a preservative, all right? And benzene has actually been known to be cancerous. And our cleaning products are laced with it, all right? So when we measure IAQ and we go into a house and we see that we have high chemicals, first thing we do, source control, we start to look to see what could be causing that. Okay? Now, as far as the measurement goes, we're looking for that same cubic foot of air, all right, basketball of air, and we're looking for levels to be below 500 micrograms per cubic meter. Above that, here's the bad stuff that happens. Pink eye, nose irritation, you got a headache, liver problems, bloody nose, that list goes on and on and on. So I'll tell you, out of thousands of houses we tested, and in high 98, 99%, we walk into a house that has a VOC problem, okay?
Talking about VOCs, you know, our measuring devices typically will measure TVOCs, and although Air Advice has added formaldehyde, which is a great addition, I'm really pleased to hear about that, but when we're looking, we got like, there's scads of VOCs, we got 16 prominent, and you mentioned formaldehyde and benzene, but you got thiolene and xylene. What's your take on measuring TVOCs and really being able to understand more? Do you use handhelds to kind of separate those out?
We don't. We know that benzene and formaldehyde are the two most prominent, right? They're the two most prominent. They're in most of the cleaning products we have. So the assumption we make is when we measure those two most prominent, we know the others are there, okay? We're gonna talk about, once we have a high level, how to treat them, how to use a strategy to eliminate them. But we know that there's many that exist. When we measure those two prominent two, we know that the rest are there. Yep. Good question. Now, with other things, we use source control, all right? I need to eliminate the source of whatever is causing the chemical, okay? Here's some guidance from the EPA. Use products as intended, follow their instructions. Does anybody have any special concoctions or elixirs that they make at home? Typically frowned upon, all right? Buy limited quantities. You wanna avoid mixing chemicals. I like to store chemicals inside a sealed container. So instead of having them loosely placed in my cupboard underneath the sink, I like to take them out, put them in a box with a gasket on it, and then store them if possible, all right? And the minute you move into a new house and it has fresh carpet or you get new carpeting, have it dry cleaned, all right? Your clothing, you buy a nice shirt from the department store, have it dry cleaned. It's laced with formaldehyde, which can cause issues, okay? Now, there are some technologies that will actually go and destroy chemicals called PCO devices, all right? This PCO uses a UV light and catalytic oxidizer. You install it in a duct system and it destroys the VOC. Now, we don't recommend these because they create water and carbon dioxide. And guess what? They're IAQ issues that we're trying to eliminate, all right? So with that, we're going into carbon dioxide. Carbon dioxide is a naturally occurring gas, and it gives us a reference point when we measure it of how well ventilated that house or building is, all right? It can reach unhealthy levels in a home, and it creates what's called the sick building syndrome. That's what the EPA coined it as. And it can cause fatigue, headache, breathing difficulties, nausea, poor vision, and itchy skin, all right? High levels of CO2, all right? Now, what's high? The EPA recommends a maximum of 1,000 parts per million. However, 750 are still considered high to me. I like to see mine below 6, all right? The higher level of carbon dioxide means that we are rebreathing a certain fraction of somebody else's exhaust gas, all right? So if you're exhaling and we have high CO2 levels, that means your neighbor next to you, the person next to you is gonna inhale some of that, all right? So real high levels are really unhealthy. All right, and that's what that rebreathe fraction is on the screen here, all right? With a high level of 1,217 parts per million, about 2.5% of that is being rebreathed, all right? And this is usually what creeps homeowners out when we test and we see that they have a high level of carbon dioxide. All right, causes of elevated carbon dioxide in a home: no or a lack of ventilation, tightly constructed buildings, and improperly vented combustion appliances, all right? How to manage it, if you can source control, like with the combustion appliances, but we like to implement ventilation strategies to help control that high carbon dioxide level. So in our building science courses, we have two phrases that we help people understand that ventilation is really important. And we use dilution as the solution, and we use to eliminate, ventilate. When we use those monikers, it helps people to understand that ventilation is really important, especially in controlling our carbon dioxide levels. All right? Next, we're going to talk about carbon monoxide. Carbon monoxide, as you know, is odorless, colorless, tasteless, poisonous gas. It's impossible to detect without instrumentation. All right? When we look at carbon monoxide, we got two types of exposures. Both are bad. The first one is chronic. Chronic is smaller doses that you get over a longer period of time. And then acute is large doses, those big events that we see. And like I said, both are harmful. All right? Reason why carbon monoxide is bad, the actual molecule attaches to your blood, carboxyhemoglobin, the blood carrying capacity, the oxygen carrying capacity of your blood. Carbon monoxide attaches to it over 200 times faster than the oxygen molecule. So if you will, your body actually prefers carbon monoxide. Now, here's something that's scary. Carbon monoxide can give you flu-like symptoms at low levels. And if you're in that environment for a sustained period of time, they can be irreversible. So testing for carbon monoxide should be absolutely something that everybody is doing. All right? Symptoms include headaches, dizziness, chest pain, nausea, other flu-like symptoms, and if you get large doses, death. Okay? When looking for issues with carbon monoxide, you definitely want to control the source. All right? Do I have an unvented space heater? Are my combustion appliances malfunctioning? All right? Is everything being vented outside? Do I have a gas range and I don't have an exhaust fan to take the exhaust gases outside? All right? Things you want to look at. You want to check these things: your gas fireplaces, your combustion appliances, your boilers, your furnaces, your water heaters. You want to look at generators that may be stored too closely to the home. All right, all those things are fair game when looking for carbon monoxide. Now, here's a story of why we test every house. Anybody know what that picture is? Crack heat exchanger. We tested this customer's house, and we were not there for a heating system related issue. We were there to service a water heater. Deploying our monitor and testing for IAQ, we saw that we had pretty consistent levels of carbon monoxide. That customer had not recently cooked, and they did complain about feeling a little icky. Right? As a technician measured, and they saw that carbon monoxide was relatively elevated, about 25 parts per million, he started checking, and he found this, and again, he was not there for that purpose. Right? So if you're not testing IAQ, you're missing opportunities. Not only monetarily, but what if that had gotten worse? Right? Could have potentially saved somebody's life. Right? So check your CO sources. All right, what about that? Do they come like that? On the left, we got a little bit of backdraft and a little bit of spillage. It's not good, right? What about your oil boiler? I'm not from the Northeast, but I don't believe they're supposed to have soot on the outside. Right? Just a guess. Right? What about that on the left? Yep. Little flame rollout action. Yep. And then on the right, if you have a buddy and you don't like them, that's how you hook up the exhaust gas. Okay? All right? So you always want to check your sources. Check all your combustion appliances. Two things need to be true. Are the exhaust gases going outside? And is the appliance producing harmful levels? All right, so you need to check those. Okay? What about that? No bueno, not good. The return static pressure about 10 times negative than the exhaust pressure. That return, inappropriately installed return, can easily overcome and pull those exhaust gases into your system. Okay? You find stuff like this with older houses all the time. If you're not testing, you're guessing. All right? You can totally find problems measuring IAQ. Okay? What about this? These are all real pictures, by the way. All right? I was always taught exhaust gases need to pitch a 1/4 inch per foot rise up and out the flue. Right? And this is ideal case of spillage. Okay? If you're not testing, you're guessing. when you deal with carbon monoxide, you have to investigate the source. All right. Here's another scary thing. Our our carbon monoxide detectors and their levels, we'll talk about that here, but here's some reference points, here's some numbers. If you look at OSHA and EPA, their standards say the average worker can be exposed to about 9 parts per million for an 8-hour time period. Back home in near Ann Arbor, Michigan, for me, our fire chief tells me that when they go into a house and if they measure ambient levels over 35 parts per million, they go on scuba or a self-contained breathing apparatus. They go on air. Okay? BPI standard says anything above 69, you're shutting down the work, you're evacuating the occupants, and you call a 911. All right? Those are reference standards that we typically follow, but here's what is being sold in the big box stores. All right? This is a UL 2034 carbon monoxide detector. All right? If you were to go to a big box store and you purchase that, and you install it, its alarm thresholds are 70 parts per million for 60 minutes. Okay? 70 parts per million for 60 minutes. But we just identified that the fire department goes on the air at 35 parts per million. Right? It's pretty alarming. Right? So one of the recommendations that we do is to put in a low-level carbon monoxide detector. This same detector won't go off if it's at 150 parts per million. It needs to be that level and higher for 10 minutes before it'll enunciate. So whenever these go off, there's an immediate danger. There's immediate danger. You need to get out right away, all right? So we always recommend low-level carbon monoxide detectors. All right. Our next parameter is gonna be humidity. And here in Florida, you got a lot of it. Yeah. I've been sweating since I got off the plane. When we look at humidity, some of the issues is occupant comfort, health issues, and then I've seen in Michigan, it tear up some buildings when we didn't manage moisture. Okay? Now, whoever you reference, whatever book you look at, ASHRAE says humidity should be kept in between the 35 to 60% mark. All right? The key is that we have to manage the humidity. All right? Now, you see, this is a humidity chart. And if you look right in the middle, we see that we have the best of none of the bad stuff that occurs if we stay in between that 35 to 60 range. And as a matter of fact, our business grew rapidly during COVID because they were all concerned about the viruses. Looking at the viruses specifically, you look at in the middle, in that sweet spot, that range we want, we see that we're in that middle buffer where things are relatively good. All right, so controlling humidity is an IAQ problem. It's one of the biggest. Okay? When you control humidity, obviously you want to look at the source. All right? You want to control what you call bulk water issues, such as your plumbing leaks, your open sump pumps, and your roof leaks. What about properly sized air conditioners? That's definitely a problem in this neck of the woods. If air conditioners are oversized, we can't get rid of that humidity. All right? Now, back in the Midwest where I am, where we get relatively cold, people buy humidifiers. Right? They'll artificially add moisture to the air because it's too dry. And testing for IAQ, we may be chasing where we need to sell that customer an appliance when really it's a building shell problem. The building shell is leaky and it pushed all that conditioned air out of the winter. We brought in relatively drier air and reduced our relative humidity. All right, so testing IAQ has many benefits, and it typically takes us and the customer and we drive down a building science rabbit hole. We're able to find a lot of stuff and help them out. Okay? Our last parameter is temperature. Now, many people won't view temperature as an IAQ issue. I tend to disagree. Measuring temperature on every service call generally helps me point that there may be another IAQ issue that I need to deal with. All right? Now, first things first, we got our core staples. We need our systems to be designed properly. We got our ACA Manual J, and we have our 2 stake points. So ACA will tell you, in the wintertime, we're gonna design our systems to 70 degrees. And they say in the summertime, indoors, we're gonna design our systems to 75. If I measure temperature on a general basis in every call, and I see that the system isn't quite performing, it may lead me down a path where I can discover issues that are affecting temperature and indoor air quality. such as disconnected ducts, ducts that need to be insulated, and airflow issues. All right? So here's the process that we take for that. When we control temperature, one of the things we look, and when we drive our IAQ conversation, we take it back to the basis. Is the equipment sized properly? In my neck of the woods, it's not. Every house we walk into, we surveyed about 3,800 homes, and they all had furnaces that were oversized by 50% or more. Those same survey outlined that our air conditioners were sized by 1 ton or more. So we look at the load. We also look at duct design. All right? Inappropriate temperatures could be a testing and balancing issue. We may need to do some duct sealing or air sealing, and we may need to add insulation to the ducts if they're in an unconditioned space. Measuring temperature helps us to identify if this is the path that we need to go down. All right? And then we also have to have appropriate equipment specifications. Okay? Here's some duct sealing. A lot of the forefathers say when you're applying duct sealing like mastic, you want to apply it as thick as a nickel. Okay? If you're not using a solution like AeroSeal, you have to physically take the insulation away and seal. And you even have to seal the swivel points on elbows called gores. All right, you have to seal those as well.
With the AeroSeal machine, I know it's expensive. I'm just saying, do you feel like that houses that y'all are doing testing, it is paid for itself, that you have sold enough sealing jobs to use the machine?
Absolutely. The key to that, everybody understand this question? He's referring to AeroSeal. So to do AeroSeal, you have to buy their machine, which is costly. And when you buy the machine, you have to sell enough jobs in order to make a profit. Is that what your question is pretty much? Okay. When we do AeroSeal, the key to it, the customer has to know they have the problem. All right? Testing. By doing IAQ testing, we're able to show them that you might have high particles and your ducts are in the attic because your ducts are leaky. And we'll sell AeroSeal as a solution to fix it. So absolutely, we see huge benefits by sealing ducts. Yep. Test before and after. The AeroSeal machine itself actually performs a test to show you the leakage once you seal, and then it shows you the post-leakage. And on average, we get in the ducts down to 2% leakage, and we're starting at 30%. Huge savings. Good question. All right. Any other questions? So now let's talk about the V. Don't forget the V, ventilation. All right? Now, ventilation, I like to call it a silver bullet because it has the ability to improve many of the parameters that we've been talking about. All right? You ever had a really strong glass of lemonade? Maybe it was too sweet, and what did you do to it? You cut it, right? You cut it. You add a little bit of water. You diluted it. All right? Ventilation has the capability of diluting those particles, and carbon dioxide, and humidity, carbon monoxide, and chemicals. So a really good ventilation strategy can help improve a lot of indoor air quality parameters. All right? Now, we've been hearing this a lot, and I used to hear it all the time. People say that a house needs to breathe. Anybody ever heard that before? Yeah? All right? That grinds my gears when I hear that. A house needs to breathe. All right? When they say that, maybe those individuals are trying to say that a house needs ventilation, but when they say a house needs to breathe, you can't control that natural air leakage, right? So how do you know if it's benefiting you or not? You really don't, all right? So when we look at a house needs to breathe, you gotta take into effect what's causing the house to breathe. Is it the wind, all right? As I push air out of a box, if I push 1 CFM out, 1 CFM comes in. The wind can cause it. What about stack effect, all right? Stack effect is a natural air movement that can go inside to out and come reverse in the summertime. Or what about if the house is depressurized by combustion equipment? You can't control the leakiness of the house, right? You can't control it enough for it to be used for ventilation. So as a result, we have ventilation standards. Anybody ever heard of this, ASHRAE 62.2? All right? Ventilation standard tells you how and what to do for ventilation strategies, all right? In our business, when we're deploying a ventilation strategy, we like to look at the building. We like to look at the conditioned floor area, the building occupants, which are the number of bedrooms plus 1, and then we use the most recent or accepted version of ASHRAE 62.2, and we come up with a ventilation strategy, right? In a nutshell, how it works, we're looking for the square footage of the home, and we're looking for the occupants, and we're gonna come up with a number to help us identify what size of a fan to use. Now, when I come up with that fan number, I have to deploy the strategy, and we're gonna talk about those next. And this next slide is a free DOE tool, and I don't know if you all have used this or not. This is called RedCalc, right? RedCalc, free tool, and if you scan it, it pulls up the link for RedCalc, and this will take you to that tool. And the tool is pretty neat. We'll drive through an example here. In this tool, you pull it up, and you pick what version of ASHRAE 62 that you're gonna utilize, okay? In my neck of the woods, we're gonna go with 2016. And when you pull it up, you have to give it specific inputs. So some of the inputs are, is the house existing or not? All right, is it detached, meaning single family? And am I gonna use an infiltration credit, which means, am I gonna take advantage of the shell leaking to provide ventilation air, all right? Then you're gonna put in your weather data. All right, back home, Detroit Metro Airport is my closest airport station, and then we get going, all right? In my business, I don't like to use the infiltration credit for the same reason that we just discussed. The delta T between inside and outside your house is what drives airflow through your building shell, all right? So back home, it's around 20 degrees right now, and it's 70 degrees inside. I got a 50-degree delta T. My shell is gonna leak the most. But what about a 60-degree day or 70-degree day? I may not get that shell leakage. So I personally don't like to use the infiltration credit. And what it does, it changes how large of a fan you're gonna use. So looking at the left, if you drill all the way down, and if I put in a blower door number, right here I got 1800 CFM50, it tells me if I take advantage of the shell leakage, my fan is gonna be 32 CFM. I need to purchase a fan to deliver that to maintain ventilation. However, remember that natural ventilation is only gonna take place when I have a relatively large delta to drive the air into the house, all right? So my preference when I design systems, I say no, I don't wanna use an infiltration credit. I wanna design my fan, and I wanna know exactly what my fan measurement is, and then I wanna purchase controls to respond when I need ventilation. That's how we do it. Because I can't depend on the shell leaking. I don't know where it's coming from, okay? So when we talk about ventilation strategies, there's three types. You got supply only, which brings in air from outside in, and it's an energy penalty, meaning that I'm bringing unconditioned air in and I have to clean it, humidify it, dehumidify it, all that good stuff, right? Then I got exhaust air, exhaust only, where I'm taking conditioned air that I pay for and I'm gonna get rid of it. All right, guess what? 1 CFM out, 1 CFM in, I'm gonna bring in unconditioned air that I gotta pay to condition. Both of these affect building pressures, so I may have an issue. My favorite ventilation strategy is to go with one that is balanced, where I don't affect the building pressures, and if I get an ERV or HRV, I can recover BTUs, okay? All right, here's an example of an exhaust fan. All right, we're in the bathroom taking a shower. You always want to have that terminated to outdoors, and the fan and the ductwork have to be sized appropriately to remove enough of the moisture and air outside for it to work appropriately. Some people and some weatherization agencies, they may use an exhaust only because it's one of the cheapest ways to deliver ventilation. I personally don't like this way to do it because if I exhaust air and I'm using that exhaust fan for my whole house ventilation strategy, I don't know where I'm bringing my fresh air from. What if I bring it from a crawl space that's full of fiberglass fibers and rodent feces and a little bit of mold, right? I don't know where I'm bringing that air from, so again, not my favorite, okay? Here's supply only. We're taking fresh air from outside and we're gonna positively push the air inside the building, all right? And when we do that, I'm bringing fresh air in, however, I have to pay to condition it. All right, again, not my favorite, all right? This is balance, where I'm taking exhaust air out and putting exhaust air in. This is a balance. It doesn't affect building pressures. However, I didn't recover any of my BTUs. Here's my favorite. Back home, we use ERVs because of our climate zone. When we use the ERV, I size it appropriately based on my fan rating when I design it through RedCalc. When I design my fan rating, I take my ERV and I hook it up, I appropriately size the duct, and I integrate it with the heating and cooling system, and I put controls. And when I put those controls, that ERV will respond when I need ventilation. If carbon dioxide goes high, it will trigger the ERV. All right? So this is my favorite. I get the ventilation strategy I want. I also get to recover those BTUs that I already paid the utility company to condition the air. Okay? All right, with that, we'll take some questions.
Hey, so with the ERV, when you say you use it to control when you have carbon monoxide, like, what, Doc?
Carbon dioxide?
Carbon dioxide levels that's too high. So what is controlling, what's turning on the ERV? Like, what control are you using, and do you have a reliable one that lasts long, or do you have failure with sensitivity or things like that?
Oh, very good question. Our manufacturers that we use, they also make sensors that will respond to the different various IAQ parameters that we want. Say high particles, they will send a signal to energize the ERV and bring it in service. Yep, good question. Chris?
Hey, Brynn, got a question. If you've got an ERV has an efficiency rating of what it can do for work. So you get your BTUs back, but you get a percentage of them back.
Correct.
How do you handle that in your load calculation?
Oh, very good question. Very good question. Everybody understand this question? All right, you're not obtaining enough energy back to call it a balance. It's so small of a loss that typically we ignore it. Yep. Typically ignore it. Good question. Any other question?
So, in the question of making ventilation more affordable, I guess, because that's what I think is a big issue as why it's not as common probably. In terms of using control methods to monitor like outdoor humidity and dew point and stuff like that, and just possibly a manual damper with running the conventional fan for like 15 minutes maybe, is that a good method, or is that just like not at all because, you know, no type of conditioning?
Very good question. Everybody understood this question? So basically he was saying there's other ways that are cheaper, right, to run ventilation. And with those cheaper ways, are they effective? So in my experience, I don't like those other ways. We'll take supply only. In our neck of the woods, there are building codes that allow for fresh air to come and dump into the return, right? All right. What has to run in order for that fresh air to come into the system? The fan. What if you're in a mild season where your temperature inside and outside are relatively close? Is your system gonna run? Unless the customer deliberately planned on ventilation. So usually when we test it, it's a slave to the blower motor being energized, and we see high levels in shoulder seasons. So not my favorite for that reason. Same thing with exhaust. When you run an exhaust fan, you have the same issue where if you think about a whole house exhaust fan, somebody trying to achieve ventilation for the structure in a bathroom, once you close that bathroom door, all right, you're bringing air in, you also can't control where the air is coming from. Yep. So I personally have measured, and I didn't like those. Yep. My best results have been coming deliberately controlling ventilation. Got a question over here?
Last question.
Yep.
So just curious, the other methods are, I think most people agree, not as good as HRV, ERV, but if the choice for a particular customer is supply only, exhaust only, or no ventilation, would you do it or not do it?
We still would do it.
Okay.
However, when we promise the results with the ERV, they just won't be there with those traditional methods. So the customer just has to be made aware, Steve, that they're gonna have elevated levels because we couldn't control it. Yep. Thank you all. Yep.
Thanks for watching. If you're willing, give this video a thumbs up and drop us a comment. Don't forget to hit that bell icon to stay updated with all of our future videos. And as a quick reminder, HVAC School isn't just a YouTube channel. Dive deeper with us at our main website, hvacrschool.com. Curious for more knowledge on the go? We've got you covered. Tune into the HVAC School podcast, available on all your favorite podcast apps. And while you're at it, join our thriving Facebook group. Also, don't miss out on our free mobile applications available for both iPhone and Android. We're all about community. For techs, by techs.